Hello. On the quiz, a lot of people got caught up in a situation like this, where they noticed that we're always dividing by 5, and then they correctly guessed that this was exponential, and they said maybe it's 5 to the x, and then they proceeded to fiddle around a lot with scaling factors and shift factors and things. When we originally did these kinds of problems, I gave a way of thinking about these that I think is helpful that I want to reiterate. And that way of thinking about it is, let's think about equations as if they are a set of directions for how to find the y value given an x value. And you'll see what I mean very quickly. So let's look at this function first. Here we are clearly subtracting by 2 each time x goes up by 1, so y subtracts by 2. So if I imagine some x value that's an integer that's much larger than 4, somewhere down here, we could think, okay, so how could I describe to someone how to calculate this y value? And you could describe it as a starting place, and then how many times you have to repeat an operation from the starting to get to where you're going. So here I'm starting from 20, and then I have to subtract 2 over and over and over again. So I'm going to subtract 2 a particular number of times in order to get down to x. Okay, so how many times do I have to subtract 2? Seems like if x is 2, I've got to subtract 2 twice. If x is 3, I've got to subtract 2 3 times. So it seems like if I'm trying to get to x, I have to subtract 2 x times. And so now I've got the equation y equals 20 minus 2x, which of course you could have gotten in a number of other ways. But my point is, this equation you can actually think about as a set of instructions for how to get to where you're going from a starting value. So thinking in that same way over here, let's pretend I have a positive integer value x down here somewhere, and I want to do the same thing. I want to say I'm going to start at 500 and do something over and over again to get down to there. So we could definitely keep thinking about this as dividing the y value by 5 each time x goes up by 1. Remember, dividing by 5 is the same thing as multiplying by 1/5. And we talked about there being sort of a constant multiplier. And I was interested to see that a lot of people didn't, like, you went with the visual pattern and you didn't think like, okay, so what did we learn about exponentials, and kind of go with the multiplying pattern, which is okay. I just wanted to point that out. So going back to this idea, we're starting with 500 when x is 0, and then over and over again we are multiplying by 1/5. So if I multiply by 1/5 once, that looks like this. If I multiply by 1/5 twice, that would be squaring it. If I multiply by 1/5 3 times, that would be cubing it. So how many times do I have to multiply by 1/5 to get down to x? Well, it seems like it's the same thing. It's like, if x was 3, I'd need to multiply by 1/5 1, 2, 3 times. So if I'm trying to get to the row x, I'd have to multiply by 1/5 x times. And of course you would want to double check your idea, like let's plug in some numbers, make sure that they work. But that same concept would very easily let you arrive at this solution. Just to show you that you could have gotten it the other way, let's pretend we're only thinking about it as repeatedly dividing by 5. So I've got 500 and I'm dividing by 5. Maybe once, maybe twice, maybe 3 times. So you could imagine squaring this or cubing this. I'm dividing by 5 how many times? X times. So these two equations are equivalent. Yeah, I guess maybe I don't want to say more about that, but hopefully you see that those are equivalent. And just to round things out, let's pretend that we don't really know the y values around x equals 0. So we're forced to start somewhere else. Like, let's say we only know that when x is 11, y is 500. You can still apply the same idea. So let's think about it this way. So I'm going to start at 500, and I'm going to over and over again multiply by 1/5 in order to get somewhere. But let's think about how many times I'd have to multiply to get to an x value that's greater than 13, say. Or let's pretend the x value is 13. If the x value was 13, I would need to multiply by 1/5 twice. If x is 14, I'd need to multiply 3 times. And so the question is, given what x is, so if x is 13, I needed to do it twice. X is 14, I needed to do it 3 times. It seems like I always need to multiply x minus, is it 11? Let's think. So 13 minus 11 is twice. 14 minus 11 would be 3 times. So you can come up with an expression that tells you, depending on what x is, how many 1/5 you have to multiply by. And this is also a perfectly great solution to this problem.